Recording started.
Hey guys, this is the demo video for homework 6. In this video, we're going to be talking about linear equations and a little bit more about slope. We're going to look at it on a graph. We are also going to be talking about some functions and how you can tell if something is a function or not. You need to read section 4 on linear functions, part 1, and section 4, part 2. You should have already taken your 4 quiz 3, and after you read all that information and watch this video, you should be ready to conquer homework 6. So here we go. Okay, a function is a relation in which each element of the domain is paired with exactly one element of the range. And what that means is that your x values, your domain is your x values. It's paired with one element of the range, your y values. Okay, that might be somewhat difficult for you to kind of keep straight in your mind. Which one's my x, which one's my y? Put it in alphabetical order. D in domain comes before R in the alphabet, and x in the alphabet comes before y. So D goes with x, R goes with y. And a relation, that's just a set of ordered pairs, okay? So if you had your 1, 4, or 1, -5, and 5, 1, and 5, 2, and 8, 7, those are ordered pairs, and it's a relation. What we want to do is we want to tell if this relation, this set of ordered pairs, is a function or not. All right? And whenever you're looking at problems and it looks like this, you want 1x to go to 1y. So here, this 1 only goes to that -5, so we're good there. But whenever you look at this 5, it's going to the 1, but it's also going to the 2. So that means that this 5 is used 2 times, and that can't happen for a function. So no, this one is not a function, okay, because this x value goes to 2 y values. If we look at this one over here, this x value goes to 1 y value. This x value goes to 1 y. This x goes to a y, and this x only goes to 1 y. So this here is a relation. All right? Now then, let's say these 2 arrows here were flipped. Let's say this -5 went to 2 numbers. That's okay. If your y's repeat or go to 2 numbers, that's fine. But if your x's repeat or go to 2 numbers, that's not okay. All right? You might see this also in a table. If I was going to set up a table, I would have 1, -5, 5, 1, 5, 2, and 8, 7. Sorry, I didn't leave enough room. But whenever you're looking at your x's, you see how these 5s repeat? You have 2 5s for your x's. That is not a relation. Your x's cannot repeat, okay? Here, your x's wouldn't repeat. So that's the difference. That's how you tell if something is a function or not. Now, when you're looking at a graph, you get to do this neat test. It's called the vertical line test. All you do is you take a straight line, draw it through your function, draw it anywhere on your function. You can draw it multiple times if you want. If it only crosses that function once, then it's a function, Okay, if this vertical line only crosses your graph once, it's a function. So yes, this one is a function. Over here on this circle, I draw a vertical line through my circle, and look, this vertical line crosses it 2 times. So that is not a function. Okay, not a function because that vertical line crossed your graph 2 times. If it only crosses it once, like it only crossed it once there, once there, once there, once there, that's a function. So you're good to go. Not a function. So difference between the two, just do the vertical line test. For slope, okay, we've talked about finding slope whenever you're given 2 points. Whenever you're looking at a graph, you want to measure the rise over the run. Because remember, for slope, we found the change in our y's over the change in our x's. We subtracted y's, we subtracted x's. And this triangle here is shorthand for change in. So change in y over change in x. That's why we say you're measuring the rise over the run. Sorry, my handwriting's getting a little sloppy. You have your rise over run because your y's are rising. Your y's are going up and down. Your x's are going side to side. So if I wanted to find the slope, I would pick 2 coordinate points. And I'm going to make my pen a little bit thicker. So I have that coordinate point there. And your next coordinate point, you want it to be where your graph crosses right in the middle. Okay? Like, I wouldn't want to choose this coordinate point right there because it's not exact. It's in between lines. You want it to be right on a line. Like, I could have chosen that point right there. I now want to do my rise over run. I went up 2, so my rise is 2, and I went over 1. So my slope for this graph is going to be 2 over 1, which is the same thing as 2. Change my pen back to black. You've seen this formula before. We used it in homework 5. You're doing your change in y. You're subtracting your y's over the change in x, subtracting your x. So to find the slope of a line passing through these coordinate points, I have my first coordinate point and my second coordinate point. So I'm going to do y2, which is -1, minus my y1, which is 7, over x2, which was 4, minus x1, which was also 4. I have -1 and -7. That's going to give me a -8 over 0. Now then, with fractions, you cannot have a 0 in your denominator. So your slope on this one is undefined, and you can just write UND, undefined. All right, that means, remember we did rise over run, that means we're going down 8, but we're not running any. We're not going side to side. So we have a vertical line for this one, okay? So your slope for this problem is undefined because you cannot have a 0 in your denominator. We are going to find the slope of these points. We take our y2, which is 2, subtract it from the y1, which is -2. Remember, you still have to write -2. because these two negatives are going to become positive. And then I have my x2, which is negative 4, minus my x1, which is negative 3. So that's going to be a positive 3 because two negatives make a positive. 2 plus 2 is 4 over a negative 4 and a positive 3 is going to give me negative 1. I can simplify this for my slope to be negative 4. On this problem, again, your y2 minus y1, so I have 5 minus 4 over x2 minus x1, which is a negative 2 minus 1. 5 minus 4 is 1 over negative 2, and a negative 1 is going to give me a negative 3. So I have a negative 1/3 for my slope. All right, this one is a little bit tricky. It's a little different. They want you to find the value of x so that these points will have a slope of negative 3 over 2. Set it up in your formula, like what we've always been doing, our y2 minus y1, so negative 1 minus 5, over our x2 minus x1. So I have 8 minus x. And they told me that my slope is a negative 3 over 2. Okay, you remember how we have always simplified our slopes. So you need to keep that in mind when you see something like this, because more than likely this slope has been simplified. It was larger numbers and they simplified it to make it smaller. So whenever I combine these numbers here for my change in y, I have a negative 1 and a negative 5. That means it started out on top as negative 6. And it went back to this negative 3. So you need to ask yourself, how do I go from negative 3 to negative 6? Well, if you multiply it by 2, negative 3 times 2 will give you negative 6. You can figure this out by dividing the 2. Negative 6 divided by 3 is going to give you 2. Since I multiplied the top by 2, I'm also going to multiply the bottom by 2. 2 times 2 is 4. So my slope started out as negative 6 over 4 before they reduced it to this negative 3 over 2. The reason why I did this was because I needed to find what this number was beforehand so I can set my denominator equal to that number to solve for x. So I have 8 minus x equals 4. To solve for x, I subtract 8 from both sides. Four minus 8 gives me a negative 4. So I have negative x equals negative 4. Remember, it's like you have a negative 1 here, so I need to divide by negative 1 on both sides. And I found that my x equals 4. If you had questions on this problem, write down the question in your margin on your piece of paper right now and take it to Toga. All right? Write down your question. Say, I got lost whenever she found what the denominator was, or I didn't understand how she got the 4 to begin with to set the 8 minus x equal to 4. Okay? Write your question down and take it to Toga because you will have problems like this. They will be showing up. Function notation is f of x, all right? It's used in place of the y value. F of x, y, it's the same thing. So if this f of x can be u, You can replace it to y, but you don't have to. You need to get used to seeing it as f of x. We have f of x equals 3x squared plus 4x minus 2. And they want you to find the value of f of negative 3. Now then, this negative 3 took the place of what? That's right, it took the place of the x. Negative 3 went in for the x in your parentheses. So what do you think you're going to do with this negative 3 in your function? Perfect, you got it. You're going to plug that negative 3 in for x. So I have 3 times, I'm going to put negative 3 in for x, and you have to remember to put it in parentheses because of the negative. So I have negative 3 squared plus 4 times negative 3 minus 2. You're going to do your exponents first. You have negative 3 squared is going to give you 9. So you have 3 times 9. I have a positive 4 times a negative 3, which is going to give me negative 12. And then I still have this negative 2. My next step is I need to do this 3 times 9, which is going to give me 27. And I have negative 12 and negative 2. So you can plug all that in your calculator. 27 minus 12 minus 2, and that is going to give you 13. So f of negative 3 equals 13. Here's your answer. I'm going to help you take this a step further. All right, your x was negative 3. You found f of negative 3 to be 13. That's your y value because remember, your f of x is the same thing as y. So there's your coordinate point. That's how you can take this and make it into a coordinate point. You took your x, you plugged it in for this function, and you found 13. If you were to look at your graph, if you were to graph this and look at where your x is negative 3, your function is going to cross at 13 on the y. All right, remember, if you had questions, write them on your piece of paper right now because I promise you, once you get to TOGA, you're not going to remember what they are. So write them down in the margin of your notebook paper, or you can go and put them in the raise your hand in the LMS. Now you should be able to recognize functions in mappings and graphs, be able to find the slope of a line through 2 points, find missing coordinates of points if you're given the slope, and be able to find function values. I hope you found this video useful, and we will see you later. Bye, guys.